Hello, everyone. Thanks so much for coming. My name's Sam. I'm going to hopefully follow up that talk with something quite different. I haven't got a joke about a sofa, but let's get started. A bit about myself. I've been at Skyscanner now for just coming up to 18 months. Skyscanner, for those of you who don't know, it's a travel search app, website. Allows you to find mainly flights all around the world, finding the cheapest deals, comparison, that kind of stuff. Handling sort of millions of customers a day, I think around 100 million per month. So yeah, what are we going to be talking about today? First of all, what is an API gateway, for any of you who aren't aware? What do we use them for at Skyscanner? What problems have we had with them and how have we kind of coped with them? And which ones haven't we fixed? And then what do we want to do in the future to kind of make sure that we're continuing to evolve, continuing to scale. So first of all, what is an API gateway? Now, we're at Microservices meetup, so I'm hoping that some of you have heard of microservices. Now, microservices are great at providing us an isolated environment that really separates a small amount of code and isolates it from everything else. This can really reduce complication when you're developing, especially if you've got multiple teams trying to contribute to a larger system. But there's certain features that you might try to add to your microservice, such as key authentication, that any requests you've got coming in, you might want to check, who is this user? Should they be accessing my API? What about rate limiting? Who are these users and how much are they using my API? Is a single client accessing my API too much? And maybe that's ruining the experience for everyone else. So you've got bots scraping your site. I'm sure you know what that looks like. What about cross-origin? If you've got multiple websites accessing your API, that's something else you need to implement. HTTPS, security getting on your back. You need to make sure all your users are redirected to that. And IP wireless. I'm sure that there's other things you might want to implement that are starting to make your microservice look not very much like a microservice. And just remember that it's not just going to be your team implementing this. You've got every other team developing their microservices, doing the same thing over and over. So let's go back a step. You've got your microservice, but we live in a distributed world. It's not just one, it's actually many. You put those behind a load balancer, and then all the other teams do the same thing. And then we have something else that sits outside of these microservices that allows you to implement all the things I spoke about before. And as you're sure you've guessed, this is your API gateway. This is the ingress to your microservices, and it allows you to implement all of this at a central point. And those microservices can focus on being micro. So before I go on to what they can be used for, I'll tell you a bit about Skyscanner and our technology stacks. The languages most prominently used, Java.
Let me just change this for you.
Cool. We've got Java, Python, and Node. And for each of those, we use a standard framework. And the idea of this is just to ensure that we can... Yeah, we've got another screen. The idea of this is just to ensure we've got some consistency across our tech stack. Are we back on?
Yeah.
Cool. Platform, primarily, we were running in Amazon ECS. This is all currently being moved to Kubernetes, so the last talk was actually pretty relevant. Thanks so much for that. For our continuous integration environment, we're using Drone to do our builds, and Slingshot does our deployments. That's a custom in-house tool that we have, which is got a pretty rich feature set. It can deploy anything from microservices to lambdas and infrastructure by applying CloudFormation templates. One of the most recent changes for Skyscanner is we got rid of our own data centers, so we're now 100% in AWS, which has got a picture here of me cutting the cake that we got to. It's a little celebration for that. It was quite a long time coming, so I'm sure many people here are maybe in the pain of the transition process right at the moment, so I'm sure you can appreciate that. So our setup for our gateway, we use a open source gateway called Kong. It's based on sort of a wrapper around NGINX, and it provides you an API to set up its config rather than relying on sort of static files that would be more difficult to make changes on the fly. So we have our EC2 instances running in AWS, and inside these we run Kong, of course, and Hecker, which is what we use to get all of the logs on the instances off and into our data platform. Hecker is an open source project by Mozilla that's actually deprecated, but still heavily in use for us. But of course, it's not just a single instance. These sit in an auto-scaling group behind a load balancer. AWS allows you to ship your load balancer logs to S3. This just gives us a bit of a redundancy in our logging. If we have problems with our data pipeline, those files are always sat there. Kong uses RDS, Postgres as its kind of backend config storage, and that's what allows you to have multiple instances always in sync. And we used Elasticache for our rate limiting. So this allows all of the individual instances to be in sync with each other about how many requests each consumer's made this minute, and they can make decisions about whether they should allow further requests through. Now you can imagine we have our upstream services. These are the microservices that our developers produce, and any requests that come in we sort of use path-based routing to send these to the correct upstream. Now, I'm sure you can imagine it's vastly more complicated than that. Our users are all around the world, and we try as much as possible to serve our users as close to them as possible. So we use Akamai as our global CDN, and if you make a request to, say, skyscanner.net, Akamai makes a decision about whether we should be sending this request to our APAC, AWS regions, or our EMEA ones. So you can imagine a request comes in, and we decide you should head to our APAC regions, and we have 2 regions there, and Akamai does load balancing 50-50 between those 2 regions. Have the exact same setup for our EMEA regions, but at all times we have some Route 53 health checks set up that allow us to fail over those requests. So say we're having some problems in APAC, we've deployed some bad config, there's network issues and that kind of stuff. We have those health checks constantly running, and they will automatically trigger a failover, which you can see it kind of will loop around, and the request ends up going only to the healthy hemispheres. But then, so that's going to check if things like there's network issues or if our gateway is having issues in a region, but we also need to know if individual APIs are having problems. Now, I'm sure if you're living in a sort of very fast-paced company, there's a lot of effort going on to increase the number of deployments per day or even per hour, and occasionally people make mistakes. So we are constantly health checking all of our APIs. So say a request comes in and ends up at one of our regions, we proxy that to the upstream. But if one of our services was to become unhealthy, Kong, we have it set up with some active health checking to automatically fail that over to another region where that same service is running and hopefully in a healthy state. And this allows us to always serve our users with some useful response all the time. Now, occasionally you may have issues where some user requests come in and maybe we've stored something in a database that's only in one of those regions. So it's not perfect, but it allows us to hopefully get some response back to the user that will be useful for them. Great. So deployments. We're constantly making changes. I think in our team at the moment, we're probably making, I'd say, in the region of 5 to about 15 changes per day. And we try to make all of these as small as possible. So we have a automated pipeline that makes these deployments and allows you to roll this out and if there's any issues with the deployment, there'll be automatic rollback. So things like when we have our, if we want to make a change to maybe the way Kong's set up or Hecker and our logging and that kind of stuff, we build a new AMI. We have our instances on our autoscaling group. We deploy a second autoscaling group. This goes in behind the load balancer. The load balancer is doing health checks on those instances, so if they're coming up and going and never becoming healthy, they'll be killed again. This can sort of keep repeating, and hopefully you get some alarms at that point, come in and see what's wrong, and then we get rid of the old autoscaling group. Now, if we want to do something more disruptive than that, this is the diagram I showed you before with our whole stack. Now, maybe we want to make some changes to, we've upgraded the version of Kong, there's a new schema version. Or maybe we used to use like Memcache, we want to swap to Redis because it's a cool thing these days. Now, that would be something that's much harder to do by just deploying new instances. So what we do is deploy the entire stack again. The way that we have this is Slingshot, our deployment system I talked about before, can deploy our CloudFormation, and we template it with just a single name. And that name, we actually are going through the A to Z of whiskies. Skyscanner is originally a Scottish company, so I'm sure there was an influence there. And the idea is we just swap out that variable for new whiskey, currently on Highland Park, if anyone's a big fan. And as we put the new one in, the CloudFormation stacks are deployed with that new name template, and that allows us to deploy the whole thing again. We can then use Route 53 weighted endpoints to move the traffic between those two stacks at a sort of nice slow rate where hopefully we can detect any issues or any regressions, which I'll talk about in a bit. Nice and slowly, and then only once we're happy, we would then remove the entirety of the old stack. Normally a few days later, just to be a bit safe. Now, I've talked about that. I've talked about having multiple databases, and we actually have close to over 100 different APIs run by different teams at Skyscanner. So we've got config that's constantly changing, and we don't want to be a blocker in that. So I'll talk a bit about how we keep our config in sync between multiple Kong stacks and between our 4 regions. So I don't know if anyone here uses Drone. I don't think it's one of the more, got one at the back. Okay, I don't think it's one of the more popular CI tools, but it's actually pretty flexible. The way it works is you have these sort of concept called plugins. A plugin is basically a Docker image you've built, and that Docker image is run with some config that you pass it. So the way you define it is you have a drone YAML, so there's more YAML files, and essentially you define some image. Here it's our gateway image, and this, you pass it some config, so like the name of your API, whether you want HTTPS only, where these sort of API actually ends up needing to be proxied to, and a bunch of other stuff. That gets run in your CI pipeline, so when you do a git commit, essentially, and then we take that config, and the first thing we do is, this is GitHub, our source control, triggers our drone build. The first thing we do is upload that to S3. I've gone a bit far. Now, getting into S3 is really important because you think, oh, well, it's just in Git, right? Can't you always just read it from there? And that's actually what we used to do, is just go straight from drone, just communicate with our Kong API. One of the reasons we wanted to get into S3 is actually because it enabled us to do what I talked about before, which is just deploy whole new stacks side by side. We always have that config stored in S3, and we can just read it out anytime and hydrate our database. So we add an item to S3 that sends a SNS notification that adds an item to an SQS queue. If you're not into AWS, these terms might not make too much sense, but essentially SQS is just a simple queue that allows you to sort of store events that have happened. we have a microservice running called Kong Loader, that we created, that looks at that config, reads it from the S3 bucket, and will then communicate with Kong to make any required changes. So it looks at what's the current config, what's currently running in production, what API requests do I need to make. Kong then writes this to its Postgres database, and it does a little clever thing to trigger all of the other Kong instances to go and update their in-memory cache of what the API config is going on. This is quite important because if you do anything to swap out the database in the background, they won't necessarily know anything has changed. So you need to tell them to reload their config. That's caught us out a couple of times doing database restores and things like that. Now, when this is running in 4 regions, so actually we're not just copying the config to one S3 bucket, we have that replicated in all 4 regions that we run in. And when we have multiple Kong stacks in a single region running side by side, we just add a second SQS queue in there. And that means that when an item is added to S3, we get the notifications on 2 queues. We have 2 Kong loaders, and everything else is replicated. So what's gone wrong? I actually, originally when I made this presentation, that carried on for the whole of this slide, and I got a bit worried that people were going to get a bit queasy. So it now pauses. One of the biggest problems we had was human error. Before we had Slingshot doing our deployments, it was all going into the AWS console, uploading the YAML CloudFormation template, entering the parameters by hand, and clicking deploy. Now, we were trying to do a side-by-side deployment, 2 different stacks. And as I'm sure some of you have had experience with, sometimes with CloudFormation, it should work, and it just keeps not, and you've got some YAML slightly wrong. So you keep going. What happened on the final time when the engineer got it right is they got one of the parameters slightly wrong, and they weren't pointing at the correct database. Now, at this point, Kong automatically ran database migrations if it found a schema that it didn't recognize. So the instance is all started up, it's all going great. Suddenly one of our regions is unhealthy. What's going on there? Oh wait, which database is this new stack pointing at? Oh no, our production one. Can we do migrations down? Yeah, that one wasn't too great. Fortunately, the Route 53 health checks I talked about earlier kicked in, completely drained that region straight away. So it's really important to have those kind of things if you're ever going to have problems. It also goes to show why you don't do your changes to 4 regions at the same time. If you do have problems, at least we had 3 left. One of the big problems we had at the start of last year was with some custom plugins we'd written. So I think we adopted Kong probably a little too early. At this point, the only way you could do rate limiting was with Postgres to your back end, and the performance was awful. So we wrote our own little custom rate limiting. This worked great. Then the adoption picked up, and then we probably forgot about it because it was working great. At some point, the connections to our sort of Elasticache instance were causing some issues, and we thought, I don't know, something wrong, maybe this is fine. And then suddenly, big production incident, all goes bang. Too many requests coming in, too many. It was a sort of busy time of year for Skyscanner, coupled with we were trying to move out of our data centers, so more and more people were using microservices and APIs. So adoption had just picked up more than we expected, and we hadn't done anything smart like pooling connections to Elasticache, so a new one was being opened and closed for every request, not something we'd noticed early on when it was being developed. So Kong now has a really extensive set of plugins. I think if they don't fulfill your needs, then I'd be a little hesitant to write your own because it bit us, so, but maybe your mileage may vary. Upgrades have probably caused the most pain. Adopting any product before it hits its 1.0 release, I'm sure you'd expect these kind of things, but for example, in our last upgrade, there was a change to the way that Kong would try to detect the IP address for the client, because you can imagine if you've got sort of several proxies, load balancers, CDN between your instances and the client, it's sometimes a little bit hard to work out what the IP address is. In the older versions, they just used to trust that it was either the first or the last IP on the forwarded for header, and then they decided that's not very secure. We'll just take the last proxy before you hit the Kong instance, which is always going to be your load balancer. This hit our rate limiting pretty badly because we do IP-based rate limiting. So you can imagine every IP was coming in was like one of a few load balance instances. Most of our alerts are focused around returning like 500 response codes, and for rate limiting you get 429, so we didn't really have any alarms in place to set up for that. So that kind of caught us off guard a little bit. AWS network issues. These cause the biggest problems with our Route 53 health checks. They detect your region's having a problem, which it is. It's a network problem. It's nothing to do with anything you're doing. Suddenly it goes unhealthy, all the traffic gets shifted to another region, and that region struggles to cope with the demand for however long it takes you to scale up. We haven't really solved this, and it's pretty unpredictable, so I don't know if anyone else has any better solutions. And then one thing I just kind of touched on is failing over APIs is pretty disruptive. I'm sure you can imagine you're running along fine, and then suddenly one region's having some problems, you move all the traffic to another region, and suddenly that region's having problems as well because it just got a whole load of extra traffic. So plans for the future. One thing that we want to do is have dedicated sort of host names for APIs. This will allow us to do DNS-based failover. So essentially removing a region from the API pool when that service becomes unhealthy. Now this will mean that we don't have, so at the moment if a service goes unhealthy in a region, we have sort of extra latency as we sort of redirect that traffic around the globe. It'd be really great to just be able to send the traffic straight to the healthy region, subject to TTLs on DNS and that kind of stuff. Since the announcement of network load balancers supporting TLS termination, that's something that we really want to investigate because they're about 25% cheaper, and for us at least, the biggest cost in running an API gateway in terms of infrastructure is the load balancer bandwidth by far. If you look on a graph, it's like this compared to everything else. We want to do some automated region draining. We think this is kind of quite healthy for the company. It's like almost chaos engineering, and would allow us to kind of test, are our backend services going to be okay in the event of failover or up to peak in traffic and that kind of stuff. VPC pairing is something we're kind of playing with right now that will allow us to send traffic through kind of the AWS backbone between regions rather than failing over through the public internet, which is what we do right now. Better management for consumers. I showed you the nice way that all service owners get to store their own config and update it whenever they want. But that's great for APIs, but for consumers of APIs, we don't have anything like as good. It's quite a manual process at the moment. And more regions. This is something we would really want because we think it might help with the failover stuff, with the wall of traffic coming in. If our regions, well, if we have more, each one is smaller, and then a wall of traffic is smaller as well. So, if any of this sounded exciting, this is my obligatory "we're hiring" slide. Come talk to me at the end.